Okay, yeah, that seems to be working. Cool. Yep. So I'm Aidan. I haven't got any fancy slides or anything. I'm just going to go through a quick sort of 10-minute demo or so of a debugger I've been making for hxcpp and sort of why I decided to make this in the first place. So hxcpp does have a existing debugger, but I found it to be a bit temperamental, especially when it comes to suspending threads and using external libraries. So I decided, is there a better approach to it? And I thought, well, why don't we take some inspiration from the web dev world and see if we can do something similar to what they do with source maps? So we can use all of the existing C++ debuggers, but also have a way to sort of step through and view in terms of the Hax code. So that's what I've been working on for the last month or two. So I basically modified the C++ generator in the compiler to output a source maps.json file, which is a lot of JSON, which sort of describes the mapping between your Hax and C++ code. And then I've been working on the debugger itself, which uses on Windows the WinDebug library, which Visual Studios and WinDebug use under the hood, and on other platforms using LLDB. So yeah, I guess I do have some demos. So at the moment, I'm just demoing the command line version. I'm working on a debug adapter protocol version, which then allows it to play nice with VS Code and stuff. But that's not very far along at the moment.
Can I interrupt you for a second? Could you zoom in your IDE quite a bit because the stream quality is somewhat low?
I was thinking of that, yeah. So I'll zoom in a bit. I've made the I've made the console here nice and chunky, which is hopefully good enough. That's sort of the main thing here. So I've got the small Hax sample here, very basic code, which I'm going to demo some stepping stuff. The main difference is that when you compile the project, you don't need to include any external library. All you need to do is you need to make sure it builds with debug symbols, which is the easiest way. Just bung the debug flag in, and that'll do it. So once we're done, perhaps not. So we add a breakpoint, say our first function. And start. We can see it successfully hit that function. Then we can do stuff like step over it. Then we're at line 7, which is our next function. So we step into that. Let's put us down at line 24, which is down here. We step in again, and that finds us back up here. This is our closure. We can also do stuff like list stack trace. Step out. And we also just resume execution, which at the moment, because we've got a big while true loop here, will just sit forever. But we can press Control-C and we break into the debugger and then do stuff like stack list again and see where we are. So that's sort of a basic example that shows stepping works pretty well. There are still a few areas where it's a bit wobbly, but I'm working on improving those. A second little demo I've got is threads and exceptions. So it all works fine with multi-threading, and it can also pause when exceptions are thrown. Give this a second. Yep. So we just start. We can see we've got we spin up this thread here, which tries to read a file, which is a file which does not exist, and it's sort of paused thread at that exception. When we do our stack trace, we can specify a thread to look at. So thread 4, which is where the exception is, we can see info on it, and we just go thread 0, which is our main one, when we see we're in this sleep. So another thing which is quite useful is expression evaluation. So here we've got some code which has some more advanced objects. So we've got an array of option enums, we've got a map of strings to any, with one of the things is either an anonymous object or this class here. So we run it. I use hscript to be able to allow you to basically input any Hax expression, and then we try and map it back onto what we've done. So we add that there, and then start. So we've stepped over, we can evaluate our array, which will then give us what the contents of the array is. We can also index into the array if we want to be more precise. So we can index there, and it'll give us it's none, and also print out the type. So it's able to correctly resolve types there. We step over again. Now be able to evaluate our map, which we can see it's all worked fine. We can also do stuff like, let's see, Q1. We can see we can sort of type in any Hax expression and it will correctly map it up to what you wrote out in the code. Yeah, that's all of that one. And then another big reason for writing this was I wanted to try and support more native code stuff. So anyone who's used full fat Visual Studio, specifically with C# and C++, will know they have quite a nice feature called mixed mode debugging, where if you have a C# function and you call into a C++ function, you can seamlessly step in between the two, and the stack trace correctly sort of follows it, and you can it all sort of works well together. You don't have to debug in your C# and then at some point break up the C++ debugger or do it in one. That is not fully working yet. That is something I'm working on, but I've got a quick demo here to show. I've sort of got some of the skeletons of that going. So we do our stack list here. Up here, we basically find a very small just C++ function, which takes in a callback and invokes it. So we sort of do a trip through C++ and then back into the Hax even. So we see here, we've just got our Hax functions. If we do all, we start to see all of the native frames in between. And we can see we've got our my native func, which is defined at the top here. And if you really want, you can specify the native flag. And instead of trying to map those frames back to Hax, it'll give you all the C++. So we can see sort of hasn't resolved these back to our Hax functions. It's just kept it as C++1. And one last little native related demo. We can also start to catch C++ only errors and exceptions. So here I've defined very quickly just a native C++ struct, which just has an integer in it. I've externed it. I've used cpp.star, so that is a raw just C++ pointer. You set it to null and then try to access it. So null pointer, we can click start, and it correctly catches that and gives you a stack trace. You can't do stuff like evaluate the expression yet, but I have some work and slowly starting to get there where it's sort of tracking some of the C++ stuff of it. But yeah, that's a very quick whirlwind tour of a debugger I'm working on. There's still lots to do in terms of adding more support for stuff like conditional breakpoints, being able to filter exceptions more and that sort of stuff. And also the big one is getting it to support the debug adapter protocol, which will then allow it to be done visually through VS Code and stuff like that. So you're not limited to doing it all through a command line prompt. So yeah, that's about all. I guess once this is sort of more working, I'll probably make more of a song and dance about it and show it off more formally sort of on the Hax forums and stuff. But yeah, that's all I got for demo wise. I guess if there's any questions or anything, I'll take them. If not, that'll be it.
Yeah, has anyone got any questions? Oh, does this work well on Linux?
On Linux,
see Rhodes asked that.
So at the moment, this is all on Windows. Works fine there. I do have some support for Mac and Linux. It uses LLDB. I've been putting off doing a lot of work on that because the LLDB API is not very nice and it has caused me nothing but headaches. But at some point, yes, I'll get it working because I also want to get remote debugging working, which would probably be quite nice for stuff like Android and iOS as well. So there is some support there. It's sort of a bit in a state of disrepair, but yes, I'm planning on supporting not just Windows.
Someone, a same person asked, would it also be possible to create a similar thing for HashLink?
So I'm not sure, because this is one of the other big questions I've got with this one is hxcpp also has its sepia scripting, which compiles down to a bytecode. I would also like it to be able to have that thing where you can step in and out of the bytecode, but I don't know how the two would work together in the same way that, yeah, I'm not sure how the current HashLink debugger works and what the differences are for it. I don't really use HashLink, so I don't know
Okay, let's see.
Can I ask one?
Yep.
Yeah, go ahead.
So you mentioned this debugger adapter protocol would integrate with the UI, right?
Yes, through debug adapter protocol is a generic one like the language server protocol. So anyone implementing debug adapter protocol could then use it through a UI.
And so, what's the sort of status on that? Is that quite a difficult undertaking?
It's at the moment sort of. I'm having to rejig a bit of the internals to make it more async. At the moment, it's all sort of the whole debugger. You can't interact with the debugger until it breaks into it. I have started on that though, and I found quite a nice. Microsoft have quite a nice testing library. So I'm slowly plodding away, implementing the debug adapter protocol, which is not necessarily interesting work, but once it all works, it should work nicely. But yeah, it's just a lot of boilerplate code, really, more than anything. So I'm not sure when it'll be done. I'd like to think soon, because the whole reason that I started making this is because I wanted to use it myself. So yeah, once the debug adapter protocol's done and it works in VS Code, then I want to start dog fooding it properly on some of my own projects, and then sort of really start to see the pain points and go from there.
Does that protocol also cover things like profiling?
It does not cover things like profiling. No, it's strictly for debugging purposes. I'm not sure if there might be another common API for that, something similar to like there's a debug adapter protocol, the language server protocol, but I'm not sure. I've not looked into it myself.